So in my presentation, I'm focusing on the sodium library. So we will show you some example around this library. I will try to introduce the elliptic curve cryptography. This is quite hard topics, but I think it's important to have at least a flavor, a basic understanding of this. What is this kind of new cryptography? And of course, I will focus on PHP 7.2. So I will show you some example how to encrypt some information using a shared key. How to authenticate some information using a shared key, how to sending a secret message to other users, how to apply digital signature, how to encrypt information using the advanced encryption standard, AES, that is quite common standard for security, one of the most used standard actually. And how to store password safely. So see, this is very important. Every PHP application has user password. So how to store it in a secure way. And also, last but not least, how to derive a key from a user password, because I will show you that it's basically mandatory to don't use the user password as a secret key for encrypt some information. So this is a very bad practice. Okay, let's jump directly into the topics. So we start with cryptography. Cryptography is very hard. It's a very hard topic. So it's very difficult to design. It's very difficult to implement. It's very difficult to use, and it's hard to get it right. So, but maybe this is not the best start for a session on cryptography. But that's the reality. So it's very, very complicated topics. But there are some people that help us, and these people are, expert on cryptography, on security, and they provide this library a few years ago. That is NaCl. That is the chemical, of the salt, basically. And it's a library that is very opinionated library, so that means the author of this library choose the best cryptographic algorithm available. So it's the best tools that you can actually use right now. And it's both for networking and cryptographic. So you can basically use this library for these two topics. It's very performant, so it's high-speed software library, and it provides you encryption, decryption, signature, and so on. So all the needs that you might have using cryptography. Is basically the main author of this library is Daniel Bernstein. This is very famous professor of cryptography, applied cryptography. He did a lot of standard around cryptography, so he's one of the best cryptography that we have. And everything is open source, so this is very important. So you can use this library without pay any license or patents or whatever. And one very important part of this library is prevent the side channel attacks. That is kind of attacks that focus on the implementation of the algorithm instead of the theory of the algorithm. So actually, this is one of the most problematic problem when you try to implement a cryptographic algorithm, because there are some details inside the implementation that can be used to attack actually the algorithm itself. This is the side channel attack. This is the basic definition. So basically it's an attack based on information gained from the implementation of a computer system in general, rather than a weakness of the implemented algorithm itself. So that means, for instance, this is just an example. This is a real-life example. Some researchers try to decode an RSA key, that is a public and private key, RSA is one of the most famous algorithms out there, using power analysis. So basically, they try to analyze the power consumption of a CPU using, some tools like oscilloscope or, some instruments, and they try basically to get the key of RSA using this approach. And this is the source of the, if you are interested, you can check it out. This is the scientific article they publish. And actually it works very, very good. I mean, it's an attack that is very successful. So there are a lot of examples in the security topics around these mechanisms. One of the most used is the timing attack. So basically, instead of use an external instrument like an oscilloscope or whatever to get, because of course it's a physical attack, so you need to have access to the CPU, so to the hardware. You can think about the timing attack that is completely different. So you have a piece of software, and you're just measuring the CPU time. So you are basically running a piece of software, an encryption algorithm, whatever, on your laptop, and you're just taking the CPU time of their execution of this software. So it turns out that for specific implementation, you can get information about the encryption key. So they just give you an example in PHP. So imagine that you have to write a function to compare two strings to check if they are equal or not, right? So this is very straightforward implementation. You have the two strings to compare. You start getting the size of the two string. If the size is different, basically you can return false because you're checking two different things with different sizes, so for sure are not equal, right? If are equal, you just iterate on the length of the string, and you check each characters. If the characters are not equal, you just return false. Otherwise, if you go to the end of the loop, that means that the string are equal, right? So very straightforward algorithm. But this actual implementation has an issue, because from a security point of view, because it's think about the performance of the comparison. So that means if you are comparing two strings that are different actually from the third character, for instance, they will just escape from the third position. So it's good for performance reason, but give you some information about the size of the string, actually. Because if you are measuring the execution time, you can check it. You can try to guess the size of the string in some way. So actually, to prevent timing attack on this kind of example, you need to basically have a comparison that runs in constant time. So no matter what is the size of the string that you want to compare, you have always constantly check everything, all the characters. Of course, it's not performance, but it prevents timing attacks. So when you have security, it's always balanced between performance and security. So you always to be careful about the implementation. So this is an example that basically compares the two strings. I get the minimum of the two strings, and I just loop. So as you can see, there is no return inside this loop. So I always go for the minimum size, always. Of course, I'm doing some stuff like XOR, ER, but this is just an implementation detail. The importance of this algorithm that it runs always on the same constant time. So basically, if you want to try to attack this algorithm, you cannot have information about the size of the string, because it's always the same execution time. Actually, there is a famous attack performed by Shamir, Tormer, and Arne Osvik, these three researchers. They did in 2006, so it's quite old. But they use this techniques, attack, to basically get the secret key used in a software for hard disk encryption. So very famous. They didn't say which one, of course, for security reasons. but was very famous. And actually, it took 65 milliseconds. So that's very impressive results to get the encryption key. So it's completely unuseful. So that even if the security, the theory behind the implementation of the RAM was good, but because of this timing attack was completely, waste of time. So that means that it's very, very important to care about the implementation of the algorithm, not just the theory itself. That's why the library like NaCl or sodium that I'm going to show now are so important, because they are thinked against this kind of attack. So the sodium is basically a fork of the NaCl library. It's basically the libsodium. So if you are on Linux, it's the libsodium library. It's a fork because they basically try to simplify the API and especially the cross-compile. So basically, NaCl was difficult to port against different machines, so Windows, Linux, macOS, whatever. So Sodium is basically a fork that simplifies this process. That's why a lot of languages, Python, PHP, now they can consume the NaCl, because thanks to the Sodium. Of course, it's the same crypto primitives of NaCl, so there is no difference here. And again, it's a shared library, so you can actually use in any language. The official website is libsodium.org. The feature of this library are authenticated public key, authenticated shared key, public key and shared key signature, hashing, key hashed for short messages, secure pseudo random number generator. There are a lot of, you basically do whatever you need. They cover almost all the possible use cases. The algorithms used in Sodium are very opinionated, I would say, because they choose the best option available. So in Sodium, you can use the Diffie-Hellman key exchange function. And here there are the links. If you're interested, you can check it out in the slide. The stream cipher are just Salsa 20 and Cha-Cha 20. So these are the only two stream ciphers available in Sodium. For message authentication code, they use Poly, this algorithm. For the public key signature system, they use elliptic curve. I'm going to introduce in a while. For the password hashing, they use Argon 2 and Encrypt. So there is no decrypt here, so very opinionated. Of course, they provide also the advanced encryption standard, because it's very popular, block cipher. So it's available in Sodium. But that's it. I mean, there are not other algorithms available in Sodium by design. So there is no DES, there is not any other, legacy or old algorithm. So you are sure that if you are using this library, you are using the top-notch security algorithm available in the industry. Okay, now I would like to give you just a very basic introduction about the elliptic curve, because a lot of people, a lot of developers talk about this topic, but it's quite difficult to understand. So this is just a flavor. So I have to show you some equation. So sorry for that. So this is I told you before to start. So elliptic curve are basically kind of equation like that. So you have two parameters, a and b, and you have two variables, x and y. If you draw this equation on a plan, you will have something like this. So basically, here is an example where a is -1 and b is 0, the first example. The second example, a is -1 and b is 1. So according to this parameter, you have different behavior, different shape. Okay, let's define the sum of 2 points. So imagine that you have this curve on a plane, and you want to define the addition, the sum of 2 points on this curve. So you take 2 points on this curve, and you want to define the addition. The addition is basically provided using this picture. So for instance, let's say you have 2 points A and B, or A and C in this case. You draw a line, you go in the intersect of the line, and you go to the opposite side. So E is the sum of A and D in this example. So again, you have A and B, you draw a line, the intersection is this point, you have to flip to the opposite side, so this C is A plus B. So this is just a definition. It's a nice property of elliptic curve, because if you take 2 points random in a curve, they will at most have one intersect in the curve. So you have just 2 points, the 3 points. So that's it. So this is just a definition. So we know how to add 2 points in an elliptic curve. So now imagine that you try to add the same point. So let's choose a point P. I want to add P plus P. How we can do that? Because I defined the sum with 2 points. If I have only one, you have to imagine that this is the tangent of the curve. So basically you get, the line is actually the tangent of the curve P. That means you have to use the same algorithm that I show you earlier. So you have to intersect the elliptic curve. So the 2p is the opposite. So p plus p is 2p, and 2p is this one. So you can think to iterate this process over and over and over. So you can have p plus p, and so on. And you can, iterate this process as many times you want. So basically, find out that given P and Q, so imagine that you choose 2 random points on this curve, find key such that Q is key time P is very hard. So this is a very hard problem in mathematics. In cryptography, they try to find an hard problem to solve it. And this is actually a very hard problem in using the elliptic curve. So given, again, 2 random points on the curve, find the number of iterations that you have to provide from one point to jump to another is very hard. It's like the problem of prime numbers or logarithmic discrete numbers for RSA. It's the same idea. This is very, very hard. In fact, if you compare the elliptic curve cryptography encryption with the RSA encryption, the security that give you using a key size of 256 bits in elliptic curve is equivalent to a size of 3,000 and more bits. So that's why it's so used in security, because it's for performance reason. Okay, so I hope I give you at least a flavor of what is an elliptic curve and how to the mathematics, the problem inside an elliptic curve. So now let's jump to PHP. Okay, so we have this extension in PHP. It's available as a standard library from PHP 7.2. So if you are running 7.2, you have already Sodium in your language. If you are not using PHP 7.2, you need at least 7.0, because Sodium, this extension, is available only for PHP 7. And you can install using PECL, so nothing special here. Of course, I strongly suggest to move to 7.2. This extension provides 85 functions with the prefix sodium underscore. So we have a lot of functions that you can use. Basically, it's a wrapper of the library of the libsodium in C. It's very one-on-one, nothing different. Okay, let's start with an example. Encrypt with a shared key. So you have one key, so we are talking about symmetric encryption, and you want to protect some information. Okay, so this is the string, the message that we want to protect. You need to basically generate an encryption key, and in this example, I'm just using the random bytes function of PHP to generate a random key. This is actually a constant given by Sodium that give you the k bits, the number of bytes, sorry, the number of bytes, k bytes that you need to generate, so the size of the key, and it's actually 256 bit. So you need to provide also a nonce, that is a salt value, a random value, that is actually public information. So you can share it, you can store it in plain text. It's not a secret, but it's needed for the algorithm in order to perform in the right way. And if you have a key, you have a message, you have a nonce, you can just consume the sodium crypto secret box function. You pass the message, the nonce, and the key, and you will get the ciphertext. So very, very simple. In order to decrypt, you have to use the open function. So you pass the ciphertext, the nonce, and the key. So very, very straightforward. Very simple to use. Note that the encryption is always authenticated. So this is very important. So when you use this function, secret box, it provides encryption plus authentication. Because if you provide only encryption, anyone can change, the ciphertext, at least even 1 bit of the ciphertext. You will never notice this change when you decrypt some information. So this is very important. Imagine that you encrypt a file. Someone hack your server, it gets the file back. Of course, you cannot understand what is inside the file because it's encrypted, but it can change 1 bit, 1 byte. You can store it again in the server. And when you decrypt the information, you have no evidence about this tampering, this change. So this is why it's very important encrypt and authenticate at the same time. Because if you have an authentication system, the authentication will fail because you changed even 1 bit in the ciphertext. So this sodium encryption provides also authentication. So that's very important. Another things to remember is that if you want to store the ciphertext somewhere, you need also to store the nonce, because the nonce is required when you decrypt the information. So typically, when you store something, for instance, on a file or in a database, you put the nonce before the ciphertext. You just concatenate the 2 strings, the nonce plus the ciphertext. When you decrypt, you get the nonce, because the nonce is a fixed string with a fixed length. You can just take the nonce, and you will take also the ciphertext, and you can decrypt. Okay, question on this? Okay, it's quite straightforward. The details about the algorithm are xalsa 20 to encrypt and poly for Mac, basically, for generating the authentication. So these are the 2 algorithms used by the sodium. Okay, let's jump to another example. We want to authenticate some information. So we don't want to encrypt, we don't want to protect, just to provide the authentication. Okay, this is the example. We have a message here. Of course, is authenticated with a key. So you need to have a secret key in order to authenticate the information. So you need to generate a key here. And you can just use the sodium crypto auth, that is for authentication. You have to pass the message and the key. And it just provides a MAC. MAC is a fixed string, like an hash, basically. It's an hash plus a key. In order to verify, you have to, of course, use the MAC, the message, and the key. It is just return true or false. Nothing special here. It's important to note that the message is not encrypted. So this is just to generate an authentication code. And the algorithm used by sodium is this one, HMAC SHA-520. Okay. Another example, you want to send a secret message. So imagine that you have some users in your application. You want to be able to send a message from one user to another. So in order to do that, we need to use public encryption. So that means every user needs to generate a public and a private key, a secret key. So the public key is shared between all the other, and the secret key is, of course, secret. So if you want to send something to the example of Alice and Bob, if Alice wants to send a message to Bob, he needs to use the secret key of Alice and the public key of Bob. So here is an example. You have Alice and Bob. We generate the public and the secret key. So the function is cryptobox key pair. It will generate the public key and the secret key. With the public key and secret key, we just get this information back. And notice the size of the key. We are not talking about like RSSA or OpenSSL 2000, 3000. We are talking about 256 bits, so they are very short, because elliptic curve, as I show you here, is the equivalent of RSA, I mean, in the size. So this is the message. So, hi Bob, this is Alice. So this is the message that Alice wants to send to Bob. We need also a nonce here, so it's a random number. In order to send a message to Bob, we need to use the secret key of Alice, because Alice is sending to Bob. So I need to use my secret key, Alice, and the public key of Bob. So I just concatenate these two keys, and I use the sodium crypto box with the message to encrypt, the random value, the nonce, and the key to encrypt. To decrypt the message, of course, this is Bob code, basically. You need to use the secret key of Bob, the public key of Alice, so it's the opposite, basically, of the other key encryption. And you just get the ciphertext, the nonce, and the key decrypt. So very, very straightforward. A question on this slide? Okay. So basically, this way to encrypt information provides you confidentiality, because it protects the message, integrity, because if you change something in the message, the algorithm is able to recognize that someone has changed even one bit, and also non-repudiation. So this is very important, because if you receive a message from Alice, you can prove that the message comes from Alice, because only Alice knows the secret key according to the public key used to encrypt the message. So you get three, basically, 3 points here: the confidentiality, the integrity, and the non-repudiation. So this is very, very important. And these are the algorithms used by the public key encryption. Okay. Imagine you want to sign to generate the digital signature of a file, a message, whatever. How to do that in Sodium? Very, very simple. Of course, we are talking about always public key and secret key, so you need to have both. But as you can see here, we use a different API. So basically, we are just using the Sodium crypto sign key pair. In fact, there is a difference in the size of the secret key. This is not 32 bytes, but it's 64. So this is especially if you want to generate the digital signature. So the function is Sodium crypto sign. So you have a message and the secret key. Or you can also generate only the signature. So basically that means the difference between these two are that in the first case you have the signed message. So you have the message plus the signature. Only one string. The other example, you get only the signature, only the sign part, not the message. In fact, the signature is just 64 bytes. So you can verify the message using the sign open. You have to pass the signed message and the public key, of course, because we want to verify that the owner of the message was who is in charge of the secret key. So you need to use the public key. Or you can also verify the signature. There is this other API, Sodium crypto sign verify detached, where you pass just the signature, but you have to pass also the message, of course, and the public key. So very straightforward. Of course, the message is not encrypted, so we are just generating a digital signature here. And again, signed message, so this one, the first example, includes the signature plus the message. So if you just need the signature, use sign detached function. And again, this is using elliptic curve cryptography under the hood. Another example, you need to be compliant with the AES algorithm. This is the Advanced Encryption Standard algorithm. This is available also in Sodium using the GCM Galois counter mode way to encrypt information. So there is a very straightforward class of functions that are AES 256 GCM. Nothing special here. This acronym additional authenticated encryption additional data. This is the acronym of AAAD. It basically means that you can encrypt information using authentication plus encryption, and if you want, you can also add other information, additional data. Of course, these are public information, so you will just add this public string inside the algorithm. So you are not encrypting the additional data. Of course, if you don't want to have additional data, you can just pass an empty string. So here, the Sodium provides a function to check if the AES algorithm is available in the libsodium itself. So nothing special here. You have to generate a key because this AES is a symmetric algorithm. So you have to generate a random nonce. If you want, you can add additional public data. This is useful, for instance, if you need to provide a way to encrypt information, and for instance, imagine an email with the SMTP protocol. No, you have to specify the information about the sender, the receiver that are public, because otherwise the protocol does not work. So you need to provide this information. You can add this information as additional public data, and this will not be encrypted, but will be authenticated. So this is quite interesting. So the function is just for AES is encrypt. And you have to pass the message, additional data, the once, and the key. If you want to decrypt, there is the decrypt function. You have to pass the ciphertext, additional data, the nonce, and the key. And notice that if the authentication fails for any reason, because someone changed one bit, whatever, the return is false. So you can throw an exception here. So you can identify if someone has changed, has tampered the data. So that's very, very useful. Of course, because you need to, when you decrypt, you need the additional data, the nonce. You need to store the nonce and the additional data also. So don't forget to do that, otherwise you cannot decrypt information. Okay, this is very interesting, how to store password safely. You can use this algorithm, that is Argon2E. That is the most secure algorithm out there at the moment. Of course, security is always about moment in the time. There is not security 100%. But right now is the best alternative that we have, basically. So imagine that you have a password. You need to store this password in a database, whatever. You can just use this Sodium crypto password hash str function. As usual, the naming of the Sodium function are not so easy to remember because it's just a wrapper of the C implementation. But if you are a PHP developer, so you are familiar with this problem. So there is nothing to say here. There are two parameters, and I strongly suggest to use the default provided by the Sodium. So don't change this number, because they are basically the number are related with the way how the Argon2E is implemented. Anyway, the result is basically an hash of 97 bytes. So remember this size, because when you want to store in a database, be sure that you have enough space. If you are using the decrypt algorithm, the output is 60 bytes. So if you want to switch to argon 2, be sure that the size is the correct one. Anyway, if you want to verify the hash, there is this str verify function, hash, and the password itself. So very, very simple. This is just an example of the output of the hash in this case. So as you can see, there are some header information like argon2 ed with some parameter regarding these are basically the default parameter that we use to generate the hash. And actually this is the real hash. But you can also use argon2e in PHP 7.2 without sodium, because starting from 7.2 you can use the usual password hash function of PHP, but you need to specify that the password should be generated using the argon2e function algorithm. And the size is 95 bytes. So is different from the sodium. So that means if you encrypt something with the sodium, you generate an hash with sodium, is not compatible with the argon2 implementation of PHP itself. So you need to choose which one you want to use it. Okay, basically there is a 1D of difference here and another. That's crazy, but that's the implementation. So be careful. Okay, this is very important topics. Imagine that you want to derive a key from a user password. So as I mentioned earlier, never in cryptography, never use the user password as encryption key for an algorithm. Why? Because user passwords are very bad from a security point of view. They are not random, of course. They are predictable most of the time. If we spend enough time with social engineering, asking you some question, finding you some information, public information on social networks, etc., I have a good chance to guess your password. The name of your children, the date of birth of your wife, combination of this, and so on. This is very important. The passwords are just a little subset of all the hash code that you can use in a random key. Typically, you have 68 characters versus 256, because you usually, when a user password, you have lowercase character, uppercase, numbers, maybe a couple of question mark, point, whatever. So this is actually the size of a user password. So please don't use this. Never use to encrypt and authenticate. But you can use a class of algorithms that are the key derivation function algorithm that start from a user password and generate an encryption key. So that's the way to go. You can use, you can actually derive a key using this argon2e function. In this example, we are generating a 32 bytes key from a user password. So imagine this is the user password. You just provide a salt here, and you generate the key using the sodium crypto password hash function. You have to specify the size that you want for the key. So here you can specify even 1 gigabyte. There is no limit, basically. The password that the user password, the salt. So that means that the salt you need to store somewhere, because otherwise the output will be different each time. And these are the two default parameters. Again, remember to store the salts. Typically, you store the salts, and it's a public information, so you can just store in the message that you are going to encrypt, for instance. Okay, there are other nice, a lot of other functions in the sodium extension. Of course, they're very typical and for specific to the use cases. So I'm not going to cover it, but I would like to just to mention a couple of these other functions, like this one, the mem0 function. So this is basically a function that unset a variable in PHP and wipe the data. That means write some random stuff and after unset the memory. Because if you just unset a variable in PHP, basically internally in the PHP itself, the pointer is completely deleted, but the content in the memory remain available for the garbage collector, whatever. So from a security point of view, if you, for instance, are using some user password or this sensitive data inside your application, when you don't need anymore the object, the variable itself, use this sodium mem0 and pass the variable here. So you are sure that from this point later, no one can access the memory. Because if you dump the memory, you will get some random information inside the $secret. So this is very powerful and useful. It provides also some utility if you need to convert hexadecimal to binary or binary to hexadecimal value. And this implementation is to prevent timing attack. Because if you use the normal implementation of PHP, it's not guaranteed that a timing attack is not prevent timing attack. There is also this optional parameter when you want to convert an hexadecimal value to binary. For instance, imagine that you want to convert I don't know, an IP address, whatever, with the point or with the special character. You can just specify here the character that you want to skip from the conversion, basically. Nothing special. And also you have this constant time string comparison function that is sodium compare. It's basically, the implementation is very similar to the one that I provided in the first slide. So this basically is a function that compares two strings using constant time. So it prevents timing attack. Okay. I provided all the references that I mentioned in my presentation here. So if you are interested, you can look at these references. Some are general, some are very specific. For instance, this article from Anthony Ferrara, it's all about time, it's specific for PHP. So if you are interested in timing attack in PHP, I strongly suggest have a look at these references. And also the last, the libsodium quick reference is a very nice references for libsodium and sodium in PHP as well. So I strongly suggest have a look at it. Okay, so thank you for your attention.